So in today's video, we will discuss about Bohr's quantization principle. For that, let me take a circular orbit of hydrogen atom like this. And this orbit is said to be a stationary orbit. Then the electron traveling in this orbit should not radiate energy. And at the same time, see, there is a de Broglie wave associated with the electron, and the electron will travel in this orbit like this in the form of a wave, and it clearly shows the wave character of the electron. Okay, and let me take a section here. This one is a crust and this one is a trough, and this section represents a wavelength. Okay, lambda. This one is actually a wave, that is this one. Okay. Now the second condition for being a stationary orbit is just this, that this path, that is this circular path, should contain an integral value of lambda or integral value of wavelength. Let r be the radius of the circular orbit. What does that actually mean is the perimeter of this path, perimeter of this circular path divided by the wavelength should be a natural number, that is n. N can be 1, 2, 3, etc. Okay, that is the perimeter of this path divided by a wavelength should be n. It cannot be a fraction. Okay. So when this condition is satisfied, we call that as stationary orbit. Clear? But we know the perimeter of this path is 2 pi r, where r is the radius of the orbit, and wavelength we know that as lambda must be equal to n. If I take this lambda to the right, I'll get 2 pi r is equal to n lambda. Okay, call this as equation number 1. But we know this lambda is equal to h by p, that is according to de Broglie wavelength. Lambda is actually de Broglie wavelength. So lambda is equal to h divided by, instead of p, I can write mass into velocity. So I can replace this lambda with h by mv. That will give 2 pi r is equal to n times h by mv. That will give, if I take this mv to the left, I'll get mv times 2 pi r is equal to nh. Okay. On simplifying this, I'll get, see, let me keep this mv and r on the left itself, that is mvr is equal to, and take this 2 pi to the right, mvr equal to nh divided by 2 pi. See, this mvr momentum into, this mv represents the linear momentum. Linear momentum into r actually mean angular momentum. mvr, for a circular orbit, we know mvr is actually angular momentum. Angular momentum. Okay. Therefore, angular momentum L is equal to nh by 2 pi. Okay. Or you can write L is equal to n times h by 2 pi. Okay. So that we can define the angular momentum of this electron must be an integral multiple of h by 2 pi. That's actually Bohr's quantization principle. Bohr's quantization principle. Clear?